Right, can you hear me? Okay, good. So I think for this presentation, we're actually going to take a step back and probably start by going back a few years back to the mid 2000s. So I'm Thierry Rayna, I'm professor of economics at University Business School Paris. But before that, I spent 10 years in the UK, where I worked, among others, at Imperial College London, at the Internet Centre, and where I did take part in a European project about grid computing. And the idea of this presentation was to say, well, if we can understand better the past of cloud computing, then maybe we can get a better view of what's going to happen in the future. The whole idea kind of sort of started first a bit with distributed computing. We had this thing with SETI at home, and then a few projects. I think one was probably born around here about how to distribute computation around individual PCs, which were seldom very used. So that was quite popular, but then it became clear that you needed some kind of special infrastructure to put all these things together. And since it was the time of the deregulation in the energy sector, then the electricity grids, which enabled to put together various providers in a single market, was actually seen as an example. So grid was quite popular, around here. So cloud restarted. I mean, the word has been used for a while, but it was repopularized by, after the launch of Amazon EC2 in 2006. So grid was progressively replaced by cloud, and then we can see that it started to pick up very well after that. So our European project was about grid economics and business model. So it was a EU FP6 grant, 2.3 million euro, which lasted for short of 3 years between 2006 and 2009. And in this European project, I was in charge of the work package on business models. So it was your typical European project with, wide and diverse consortium. So with people who were economists, some from business backgrounds, computing with consultants, and also some businesses. So one of the things that did take us quite a bit of time when we started this project was, what is grid? Okay. When we talk about grid computing, and actually when we talk about cloud computing, what exactly are we talking about? So we kind of identified three things. So the first thing was what I described earlier, this network of PCs. After this, SETI at home project and things like Boeing, Extreme Web, XGrid, the idea that we could put together unused capacity of users to make it something very powerful. Was it that, or was it a network of supercomputers? Like, for example, we would see at the time in physics departments that could lend their spare capacity? Or was it basically some kind of market with centralized providers? So after thinking about it, we kind of decided that the first scenario wasn't really realistic. There were already quite a lot of problems in terms of infrastructures, and we really didn't see businesses basically hiring individual pieces. So this led us to adopt two scenarios, one which was related to network of supercomputer and centralized providers. So the first scenario was what we called a grid commodity market, and the second one was differentiated market. Right. So the idea was briefly to present you these two scenarios to see what didn't happen, what did happen, and maybe how that can be helpful for us. So the first scenario was the grid commodity market. And as I said earlier, grid computing was largely inspired by the electricity grid. So the idea that we could have a market for trading computing resources, the idea that we could have a mix of large and smaller providers that were put together, just like we have on the electricity grid with nuclear power plants, but also windmills. The idea was that we would need to have some sort of commoditized product, because if we want to have a grid that works, electricity is commoditized, so we would have somehow to have some sort of computing commodity. And all that would be put together with a form of market mechanism. So we kind of thought about a few of them: bargaining, auctions, and the usual market mechanism. So in this scenario, we went for, mainly, after brainstorming, for something that looked, again, like the electricity market, or if you prefer, like the financial market. So a few centralized marketplaces. The idea was to aim at a global market with a bid-ask mechanism. And then, you know, since it's hard to predict which resources are going to be used and when, then there is a risk. And the idea was to use something that would have, you know, like in the financial sectors or in the electricity market, forwards, options, and swaps. And on top of that, we had plenty of intermediaries, brokers mainly, so workflow brokers, insurance brokers, planning brokers, and so on and so forth. So from the computing aspect, there are quite a lot of challenges that were associated to that. So that looked like a good idea, but we kind of had a problem, is that computing is not like electricity. Well, that makes sense, but still, it's very difficult to make it like electricity. So we had some technical obstacles that were due to the fact that computing resources are multidimensionals. What were we talking about? Were we talking about clock speed? Were we talking about memory? Were we talking about storage? And that meant that, you know, if we want to have some kind of free market, open market, then we need somehow to have some kind of commodity benchmark, which was very difficult to establish. The risk of failure, for example, also had somehow to be taken into account, some kind of redundancy and so on and so forth. And that led to quite a few challenges to distribute computer processes. I mean, we've seen a few of these this morning, but, you know, I mean, can you really freeze processes? Can you dynamically reallocate memory? How does that work? How do you schedule jobs? You know, if you have a machine on which there is a job that is scheduled and it's cancelled, what do you do with the remaining time? So there were a lot of questions. There was a lot of research done about that, so I'm not a specialist to talk to you about that, but we did find some solutions, in particular with regard to scheduling, but still, this was seen as a real challenge to have a common grid market. So the second scenario was a bit different. The idea that we had providers of computing power and capacity which were of various natures. So the thing was that wouldn't be any commoditization. You would choose a particular provider because they would have a particular type of processor, particular type of storage, maybe, you know, services. That there would be some market segmentation, and we were thinking in this case there would be relatively few intermediaries. So you would have a company that would have large amount of storage or large amount of virtual servers, and that people would be using, and therefore there was very little place for brokers of any kind in comparison to the previous one. Okay, so two scenarios, which one did exist at the time? Well, that was our problem. If you come back to 2006, and if you look at grid computing, well, we're not even talking about cloud computing. So if you go back to 2006, that's how things did look like to us. You know, the Loch Ness Monster. You've heard of it, but you've never seen it. So grid or cloud or whatever has been around for, you know, quite a bit of time. Can trace that back to network computers in the mid-1990s. But the point is, you know, there was no industry, nothing. So it was very difficult to see what could happen. And in particular, the problem was that in addition to all these computing obstacles, we had some industry obstacles. The cornerstone of the computing industry at the time was obsolescence and idleness. You would have a computer that would stay idle most of the time because, well, you know, what we were making your computer do was not very demanding, but yet you had to compress a video file, and out of sudden your computer was just not powerful enough. So you had to buy a new one. And there was this planned obsolescence that was really, really embedded in the ecosystem, you know. And it was both on the software side and on the hardware side. So, you know, you needed, you know, to encode your video, so you needed a better hardware. But if you had a better hardware, then your old operating system couldn't work on it, so you needed to rebuy it and buy the software and so on and so forth. So that was one of the problems. You know, I mean, how do you have cloud? Why would you have cloud or grid if you need to change your PC all the time? Your PC was basically a Formula One anyway. The second thing is that even if we left that aside, there was little rationally for remote storage or remote computing. Network computers are nice, but they sit on your desk, okay? What's the problem of adding a hard drive in it? No problem. What's the problem of adding a more powerful processor in it? No problem. It's taking space on your desk anyway. So if you had a network computer on your desk, you might have had the full computer. Didn't change anything. So there was really no point that in the slow network of storing locally. Right. That was back in 2006. Sorry. Back in 2006. But yet it happened. Okay, so now we have more and more consumer of cloud solutions. And for these consumers, we also have more and more consumption. So it did finally happen after more than a decade. So the question is why? So one of the reasons why it has happened, first of all, well, we have more hits a wall. So the fact that, you know, the very, very driver of planned obsolescence hits a wall. You buy a new computer because your old one doesn't have a chip which is fast enough. But when new chips cannot breach the 3 gigahertz limit, how do you make people buy new computers? So you can multiply cores, but most people don't care about having 20 or 30 cores in their computer. So that's the first thing. You can't do planned obsolescence anymore, so you have to find new outlets for your chips. The second thing is that the business model, the ecosystem of the PC industry was based on obsolescence, but actually it's the PC itself that became obsolete. Okay, we have more and more people who have only a tablet or a smartphone and not even a PC, not even a laptop. And it's been a few years since the sales of smartphones and tablets have largely outnumbered the sales of PC. So again, you change business model, you have to do something else. And finally, from the industry side, there is a real reason why you would like to have users' data online. Just not only because you charge them for that, but because you can use this data to make money. So if you're Google, you do want everyone's files to be online, because that's how you make money. Not by charging them for that, of course, because of the data. Right. So, what can we learn from this episode on grids? I think what we can learn is some form of paradox. Okay. And this paradox is that, yes, we're talking about cloud, and as you can see, grid has disappeared, and cloud computing has gone up. But what do you see? It's also going down, right? Why is it going down? Because it's not really about computing anymore. When what most people associate with cloud is actually the storage. So if you add cloud storage, you can see that actually goes up. And for most people, though yes, we do have software as a service, yes, we have infrastructure as a service and so on and so forth, for most people, most SMEs, what they see in cloud is the storage. Mainly the storage. Even application software which works based on a server normally has a local copy, right? Why shouldn't they? This is computing, okay? So you can see that the most powerful phones have, for some of them, as a processor, a quad core, which is 2.66 gigahertz. So, okay, it might not be as fast as the fastest PC, but it's definitely as fast or faster than the average one. So why would you use remote computing capabilities when you can actually compute it fairly well on any mobile device? Therefore, it means that cloud has to be more identified with what you can't do on your mobile device, and that it's storing data and having synchronized with any of the multiple devices you use. Okay, well, that's all good, but that's some form of paradox, right? Because if we go back to our work at GridEcon, what made both the first scenario challenging, if not impossible, and what made the second scenario vertically integrated, what was this computing part? Okay, if you talk about calculation, about computing, there is no commodity. Okay, so that makes it very difficult. And if you talk about people offering different clock speeds and memory and capabilities and threading and stuff, you understand why they are vertically integrated. Okay? But it's not the case. A large part of cloud computing nowadays, a large part of cloud is about storage, right? Well, storage is a commodity. There is absolutely no difference in terms of storage. Okay, maybe there is difference in terms of redundancy, but aside from that, there is absolutely no difference in terms of storage between two different providers. Okay. So that means that what we were trying to do at the time that was impossible to do could be done today. We could have open markets, competitive markets for cloud storage, and we don't need such a large vertical integration as we have today. Because if we come back to the question of adoption, and if we look at what people mention, well, of course, they mentioned that concern about security, privacy, regulatory compliance, integration with the solutions of the provider, provider transparency, ability to customize, reliability, viability of providers, lock-in, the fact that they are locked in with a particular cloud solution, cross-border restrictions. You can see that really a lot of these are born from the fact that the industry is very much vertically integrated. You use Amazon's cloud, or you use Dropbox, or you use iCloud, and that is proprietary. You cannot use Google Drive and store your documents, Google Docs, and store your spreadsheets on your Dropbox. It's not possible, okay? Microsoft is starting to do that, but that's because they're really desperate. Otherwise, they wouldn't be doing it. Sorry, we have someone from Microsoft here, I think. But that's the idea. You know, if you don't have to, then you will be vertically integrated. You'll have proprietary solutions, and you'll make sure that you can lock people in. Okay? And that raises a lot of questions, because if you deal with only one provider, then there are chances that this provider will be not viable. Not viable doesn't necessarily mean that the provider just collapses. But we have plenty of examples, for example, with digital right management, when big corporations such as Microsoft or Sony decide to stop one of their particular activities and leave people in the cold out. Okay? So all these barriers could be mitigated if people would have a choice of decoupling the software solution with where their data is. You know, yes, I want to use Google spreadsheets or Microsoft spreadsheets, but I want the data to be stored here in SO, okay? Or I want it to be stored somewhere else. I want to be able to choose where it's going, okay? And that also raises issues of transparency. Yes, we mentioned it. It was here. For example, there is a very interesting study. We were talking about prices this morning. There is a very interesting study that shows that Amazon's spot prices for EC2 actually aren't spot prices at all. They are not based on demand and supply. They are based on basically pushing people towards long-term rental of their machines. So, you know, you have to trust Amazon that the price they quote for their computing capabilities or for their storage capabilities is actually based on demand and supply. It's not. Actually, it's based on it's a price discrimination strategy. But again, all that is caused by the fact that there is no competitive market for these particular resources. So the idea is that if we look at a significant number of concerns and adoption barriers, they have to deal with this problem of vertical integration. If we do remove this vertical integration and ex post incompatibilities, so not the fact that the system is per se incompatible, but the fact that companies make it incompatible so that you will stick with them, then, you know, that would work better, okay? And it's true that you cannot trade all kinds of cloud resources in an open market, but some, just like storage, you can, okay? And from an economic point of view, from the regulator's point of view, there is actually very little reasons why you would accept to keep such a closed system. So in terms of policy, there is little or no rationale for such a tight vertical integration. Again, it tends to create or to reinforce giants, which don't really need that. Okay. Google is already a giant and doesn't need the fact that it is closed in terms of cloud capacity to be a giant. It tends to hinder adoption, creates regulation nightmares. So I examined a PhD a few months ago about government clouds in the UK, and government cloud is a really, really big nightmare in terms of, you know, where the data is going, how do you guarantee security, and so on and so forth. And yet, governments don't necessarily want to use the software solution from a small company. They don't necessarily want to pay a small company to recreate Microsoft Office Online or Google Docs. That's not the point, you know. They might want to be able to use this software, but on storage that stay where it should stay. It causes security issues. That's something we don't really often see or understand, but the fact that these are locked down caused security issues. Just an example, for the ones who have Dropbox, you know you cannot use WebDAV as a protocol for your Dropbox, right? But there are some companies that actually have created a WebDAV service for Dropbox. You need to pay, but on top of that, you also need to give your login and your password. So instead of having one company that has your login and your password, you have a second company that has your login and your password. And if you do remember the latest problem with Snapchat, the problem was not with Snapchat, but with other services that were in the middle to overcome some of the limitation of the service. So this limitation tends to create security issues. Okay, so there is really a need to promote open standards and also to uncouple the software from the storage. I mean, back in the days, you wouldn't dream of not being able to save your spreadsheet or your Word file on your hard drive or an SD card you choose. Well, that's basically what's happening at the moment. Right, well, that's it on my side. Before we pass to questions, I just wanted to mention a special issue on business models and ecosystems. It's probably not the right day. I think most of the business model talks were yesterday, but there is another 5 days if you ever feel inspired. If you have any question, of course, feel free to send me an email if you want to know if your paper is in scope and stuff. And, well, if you have some questions, then I'd be happy to answer them.
I have a question. I've been surprised also. People have mentioned some limitation of interoperability of cloud infrastructure, but there's been lots of discourses and discussion about some standards to help to interoperate between the clouds. So what is your experience? What is your perspective on this? What is maybe the reality is not there, but there's really some discourse now about the clouds service provider that are kind of adopting those standards.
Well, I think that when there are open standards that could be used, to move storage around. For example, WebDAV is one of them. It's by no means the most efficient.
OpenStack. So really, some standards that are supposed to help interoperability in the cloud. Huh? I'm not talking about WebDAV, which was something old that was not really associated at the beginning with the cloud.
Well, that's a very good question, actually. I haven't heard anything particularly convincing about that recently, because the thing is that the market leaders tend to try to be not interoperable. So I think that there might be a need for a regulatory push, because in the meantime, there is no desire for that to happen, especially with regards to storage, because there is nothing easier than to move data from one place to another. It's not a particular challenge as opposed to moving jobs or processes or things like that. But yeah, surely that's something we would definitely want to see, more open standard that would enable indeed to.
OpenStack, I think.
Oh yes, yeah, actually I heard of that, yeah. Again, I'm an economist, I'm not like a computing expert, so you'll forgive me if I'm not aware of all the intricacies of that. But yeah, the computing colleagues were talking about a few things like OpenStack, for example, so I've heard of that, yeah.
What about the public regulation and eventually national or European cloud?
Well, I think that originally the idea of grid economy, of all these European projects that were funded in the FP6 and FP7 framework, was the idea to create a European cloud. The thing is, I think all that has been very much bypassed by the success, unexpected success. I think it did happen where nobody was really waiting for it. Again, this idea that grid is the storage was really not in the cards. We were really talking about more like about you have this small and medium enterprise, which is a high-tech enterprise and needs to calculate and to compute very complex calculation to create a new product, and this company would connect to European grids and would maybe rent. We actually had the supercomputer at Imperial College being on the European grid. There was one actually at the time. So that has been really bypassed by the current storage situation, where we get big providers, often non-European, that supply that. So then if we still think that, if Europe still think that it is one of the key driver of competitiveness, then indeed there is a lot of work to be done in creating some kind of European grids. So some countries are starting to do that. Some countries are requesting that sensitive data, for example, is necessarily stored geographically in the country. So it's moving, but at very, very slow speed.
The future.
Sorry?
The future.
The future of that?
The next. For example, the project, is possible the new project in Europe integrate all aspects, grid and cloud?
Well, yeah, I suppose it's possible. I think that probably one of the problems at European level is maybe because the programs have focused on what is most interesting and what we've seen today. Actual challenges, again, how do you allocate memory to processes? This is something really interesting. It's not like allocating, like hard drive space. So I think maybe one of the issues, what the focus of the research program is very advanced, which is really good, but maybe at some level not practical enough. But maybe this is not about research. Maybe it's just, we need to keep the research program on the things that are really challenging and interesting, but at the same time, should be like some regulatory move to get the easy bits like storage done and open and in a European system. I don't know if this answers your question.